Moving on to the next section, chapter 3, section 7. Graphing absolute value functions, part 1. There will be a part 2 to this, but that won't be till after spring break. We will review part 1 a little bit probably when we return before we get into part 2, or that might be a part of part 2's notes. But just know that part 2 will be after spring break. So, graphing absolute value functions. So, this makes a lot of sense actually. An absolute value function is a function that contains an absolute value expression. Pretty straightforward, right? Absolute value function is a function that contains an absolute value expression. The parent absolute value function is f of x equals the absolute value of x. So I would definitely have that written down and know that that's the parent function. What was our parent function for our linear functions? F of x equals x. Parent function for the absolute value functions is f of x equals the absolute value of x. It's the most basic form of my absolute value functions. Bless you. The graph of f of x equals the absolute value of x is v-shaped and symmetric about the y-axis. Bless you. So, here is our parent function over here to the right. Notice it has that sharp turn. It's not a curve down at the bottom, is it? It's a point. So anytime you see a V shape like that, whether it's upside down or right side up like that, it could be wider, it could be skinnier, it could be translated up or down, right or left, then you know you're going to have an absolute value function. So if you see the V shape, it's an absolute value function. This is my parent function specifically. So my parent function is symmetric about the y-axis. If I folded it over, it would match correctly. The vertex is the point where the graph changes direction. So I pretty much have two lines meeting at one point, correct? So it's where my point or where my graph changes from like a negative slope to a positive slope. Or vice versa. It could go from positive to negative. The vertex of the graph of f of x equals the absolute value of x is 0, 0, my origin. So the vertex of my parent function of the absolute value function is the origin. The domain of my parent function is all real numbers, because if we look at it going from left to right, my graph's going to keep going on forever and ever to the left, on forever and ever to the right, correct? So that's why my domain is all real numbers. My range, we're looking at it going up and down. Do I have a lowest point? What is it? 0. My graph of my absolute value parent function is not going to go below 0, is it? It stops at that 0. So the range is y is greater than or equal to 0. It's all the values that are equal to 0 and greater than 0. So there's my range. Any questions about the parent absolute value function? Notice the slope of the left side of the parent function is -1. Slope of the right side is +1. So would we all be able to reproduce the parent function if we were asked to do so? Vertex is at 0, 0. Slope of -1 here. Slope of +1 here. Everyone good? And a little note at the bottom. The graphs of all other absolute value functions are transformations of the graph of the parent function f of x equals the absolute value of x. Just like all my other linear functions were transformations of f of x equals x. Y'all remember that from the past 2 days? So if I have anything being multiplied by my absolute value, divided by it, added to it, subtracted from it, anything being multiplied inside, added to or subtracted from inside, that's going to be a transformation of my parent function. The transformations presented in section 3.6 also apply to absolute value functions. So we're going to see some of those transformations that we dealt with linear functions with our absolute value functions. So who can name some of those transformations? Reflection over
Any axis.
x or y axis.
Horizontal stretch and shrink.
Horizontal stretch and shrink. What kind of translations? Horizontal and vertical.
Vertical stretch and shrink.
Vertical stretch and shrink. And I think we covered them all. Yep. So we got our horizontal vertical translations reflecting over the x and y axis. Horizontal stretch and shrink, vertical stretch and shrink. We're going to see all those with our absolute value functions as well. Okay? Any questions before I move on? What's the shape of an absolute value function? V shape. Okay, example 1. It says graph each function, compare each graph to the graph of f of x equals the absolute value of x. Describe the domain and range. So let's just go ahead and graph our parent function. See if we remember how to do it. Where's the vertex of my parent function? Make sure we're not reading, doodling. We're not on our phones or anything like that. We're paying attention, taking notes. Where's my vertex? The origin, 0, 0. What's the slope of the left half? -1. So I can go up 1, left 1. Just go up at that angle. What's the slope of the right half? 1. I don't know. There's my parent absolute value function. Everyone okay with that? So now let's graph g of x equals the absolute value of x plus 3. Based on my past few days of talking about transformations of linear functions, if I'm adding or subtracting something outside of the grouping symbols, what kind of transformation was that? What kind of translation? Horizontal or vertical? Vertical. If it's outside the grouping symbols, it was a vertical translation. So is this getting translated up 3 units or down 3 units? Up. Remember, if it's outside, we follow what the sign says. So what I could do is, I could just take my parent function, translate all the points 3 units up. I'm going to show you another way, just in case it's not that simple. So what we can do is we can create a table of values. You guys have all seen a table of values before, correct? Mm-hmm. G of x is just my y value. And I can just plug values in. Yes?
Could the 3 be the y-intercept in this case?
Yes. Yep. 3 is going to be my y-intercept. But this isn't... Absolute value functions don't really take on a form like slope-intercept form because it's not a linear function. Does that make sense? But in this case, we will have a y-intercept of 3. Yes. Okay, so I just need to pick values to plug in. I usually like to pick some negative values, 0, and some positive values. So what might be 5 good numbers to plug in? I have 2 negative, 2 positive, and 0. -4, we can do -4. So let's plug in -4 to our function for x. So I get the absolute value of -4 plus 3. What's the absolute value of 4? 4. What's 4 plus 3? 7. So I can graph my ordered pair, -4, comma 7. So left 4, up 7. Would be another point I can plug in, or another x value. -10. Bless you. So what's absolute value of negative 10? 10. What's 10 plus 3? 13. Is that going to be on my graph? It's on my graph, but on this graph specifically, no, it's not. So let's pick another point to plug in. One that's on my graph. Negative 7. Y'all are not picking the values I thought you would pick, but that's okay. What's the absolute value of negative 7? What's 7 plus 3? 10. So I can go left 7, up 10. Everyone good with that? And then my 0. What's the absolute value of 0? Oops. What's 0 plus 3? 3. So I can go 0, 3. It's another value I can plug in. On the positive side now, 4. What's the absolute value of 4? 4. What's 4 plus 3? Right, 4 up 7. And then another value. What am I going to get? 7, 10. Does everyone see how I just picked values to plug in? Plugged them in, got my ordered pairs. The numbers I thought you guys would pick would probably be smaller. I thought you guys were going to pick like negative 2 and negative 1, just to the left of 0. And 1 and 2, just to the right of 0. This works too, though. You can pick any points you want to plug into your function.
And since it goes on forever, we could, if we really wanted to, choose like a 6-digit number.
Yeah, you could. If you had a graph big enough. Because if you get a graph that's about this size and you choose like 6 million to plug in, or 600,000, something like that, it's going to be way over here, or way over here. And you're not going to be able to guesstimate where it's at. So you're not going to have a very accurate graph. But if you had a big enough graph, you could definitely do that. Are there any questions how I graphed this one? Like I said, you could use either method. Since it's a vertical translation, I could have just done all my points 3 units up. If you notice, 1, 2, 3, 1, 2, 3, 1, 2, 3. They're all 3 units up for my parent function, correct? Or you can use your table of values. Questions on letter A so far? Okay, what is the next thing it asks me to do?
Describe the domain.
Describe the domain and range. So what would the domain of this new function be, g of x? All real numbers, why? It's going left forever and it's going right forever. There's no stopping point going left or right, is there? I'm looking at my x values, so that's why it's all real numbers. What would my range be? Say it again. Which variable? Y. We want to use y because my range is talking about my y values. So y is greater than or equal to 3. Because it's not going to go lower than 3, is it? Nope. But it's going to go on to positive infinity. So that's all the numbers that are greater than or equal to 3. Questions on letter A? Not too bad? All right. Letter B. And let me erase this graph over here. Keep the parent function on there. There we go. M of x equals the absolute value of x minus 2. Let's create our table of values. First off, what kind of transformation is it going to be? Horizontal translation. What do we know the graph's going to do? It's going to shift which way, right or left? Right 2 units. Remember, if it's in the grouping symbols, we do the opposite of what the sign tells us to do.
So add?
Well, we don't add 2, we would just go right 2. instead of, because if you see negative, you're assuming you're going to go left, correct? But we do the opposite of what the sign's telling us to do. So go right 2. So all my points are just going to get shifted right 2 units. But let's go ahead and look at the table of values and get some practice with that. So someone pick a value for me to plug in. -3. So if I plug in -3, I now have to do my subtraction first and then take the absolute value. So what's -3 minus 2? -5. What's the absolute value of -5? +5. Everyone okay with that? Someone give me another value. What? 1. If I plug in 1, what's 1 minus 2? -1. What's the absolute value of -1? 1. I'm going to graph these ordered pairs as we go. So let's go -3, 5. And 1, 1. It's already graphed. Someone give me another value. Huh? 7.
You really like the number 7 today. For some reason.
What's 7 minus 2? Absolute value of 5? 5. So write 7 up 1, 2, 3, 4, 5. Someone give me another value. What? 3. What's 3 minus 2? 1. What's the absolute value of 1? 3, 1. So give me another value. 2. 2 minus 2 is? Absolute value of 0? 2, 0. Do I see a V shape kind of forming? Yes, I do. There's my graph. As we can see, all the points got shifted 2 units to the right. 1, 2. 1, 2. Everyone see that? Okay, so let's describe my domain and range here. What's my domain? All our numbers. Once again, there's no stopping point to the left or to the right. Get your heads up. There's no stopping point to the left or right. It's going to hit all my x values. So that's why it's all real numbers. What's my range? Y is greater than or equal to 0. The lowest it's going to go is that 0 value going up and down. And it's going to go up to positive infinity. So my domain and range are the same as my parent function. Any questions on B? Questions about example 1 and vertical and horizontal translations? Those are pretty easy, right? You're just shifting the graph. Units to the left or right or up or down.
Easier than I thought.
Yep,
So far.
so far. That's the key, right? So far. Moving on. Example 2. Graph each function. Compare each graph to the graph of f of x equals the absolute value of x. Describe the domain and range. I'm going to graph my parent function real quick. I'm not going to put all the points. I'm just going to draw the lines. There's my parent function. Everyone okay with the graph of the parent function? What's the vertex? 0, 0. What's the slope of the left side? -1. What's the slope of the right side? +1. So now let's look at q of x equals 2 times the absolute value of x. If I had something being multiplied by, on the outside of the grouping symbols, was that vertical stretch or shrink, horizontal stretch or shrink? Vertical. So this is either going to be a vertical stretch or shrink. Okay? So let's make a table of values. Someone give me a value to plug in. 3. What's the opposite value of 3? 2 times 3? 6. 3 comma 6. Okay, someone give me another value. 7? 7's going to give me a point that's off the graph. So let's go for another value. 5? What's the absolute value of 5? 2 times 5? 10. So I can go right 5, up 10. Someone give me another value. 0. If I plug in 0, what's that going to give me? 0. So the absolute value of 0 is 0. 2 times 0, 0. So 0 comma 0, that's already graphed. Someone give me another value. -4. What's the absolute value of -4? 2 times 4, 8. So -4 comma 8. And let's get another value. -6. What's the absolute value of -6? 2 times 6. It's going to give me a value off the graph. -1. Absolute value of -1. 2 times 1. -1 comma 2. Does everyone see that? Does everyone kind of see a V kind of forming? We got ourselves a slope of 2 and -2. Sorry, my line's not the straightest. There's my graph of Q of X. So is this a vertical stretch or a vertical shrink? Vertical stretch. It's like I took the ends of my graphs and I pulled them away from the x-axis and they got skinnier. Make sure our heads are up, we're paying attention. So it's a vertical stretch by a factor of what? 2. But it says to describe the domain and range. Is the domain and range going to change from my apparent function? Nope. Domain is all real numbers. Range is y is greater than or equal to 0. Questions on letter A? Okay. This is our last example. Stay with me. Letter B. Last example for today. Let's see if I can get this. There we go. Okay, so if my A value was greater than 0, we saw that it's a vertical stretch, correct? If my A value is in between 0 and 1, it's a vertical shrink. If I had a negative on the outside of the grouping symbols, what did that do to my graph? There's 2 transformations going on here. Anyone remember? If I have negatives thrown in there. If it's on the outside, my negative's on the outside, it's reflected over my x-axis.
Reflection over x-axis?
Yep, so I've got a reflection over my x-axis here, as well as a vertical shrink. So, let's look at a table of values. Notice we have a fraction. If I were us, let's plug in multiples of 2. So if I plug in multiples of 2, that's going to give me nice whole numbers that aren't fractions. Okay? So, what might be a good multiple of 2?
Even numbers.
2. So even numbers. So we can do 2. What's the absolute value of 2? 2 times negative 1/2. What? Negative 1. 2 comma negative 1. It's another good one. Negative 4. What's the absolute value of negative 4? 4. What's 4 times negative 2? Or negative 1/2, I mean. Negative 2. It's negative 4. Negative 2. It's another good one. 10. What's the absolute value of 10? 10 times negative 1/2? Negative 5. So write 10 down 1, 2, 3, 4, 5. It's another one. Negative 8. Absolute value of negative 8? 8. 8 times negative 1/2? Negative 4. Negative 8. 1, 2, 3, 4. And what's another really, really good one? 0. Absolute value 0? 0 times negative 1/2? 0. 0 comma 0.
I thought someone would choose 6.
Do what?
That's just, I thought someone would have chosen 6.
You could have chosen 6. That's still going to be on our graph. 6 comma negative 3. But I do see a V starting to form. So as we can see, it was a vertical shrink. So if I would have done my shrink before I reflected it, I'm going towards the x-axis, so it's getting flatter and wider. And then I reflect it over the x-axis. So there's the two transformations going on. Questions there? What's my domain? All real numbers. And what is the range?
Less than or equal to.
Y is less than or equal to 0. Because my graph is a stopping point still 0, but it's going to negative infinity instead of positive infinity this time. Questions there? We good with that? Any questions before I stop the recording?
When is that due?
It'll be due tomorrow on campus.